Welcome to The Explainer. Today, we're talking about one single, unbelievably tiny component that, and this is no exaggeration, built our entire modern world. It's in your pocket right now, it's on your desk, it's in your car. It is the switch that powers everything digital. So, to really get a handle on this thing, we're going to tackle these key questions. What exactly is a MOSFET? How does it even work? And where are they all hiding? By the end of this explainer, you'll see exactly why it's such a huge deal. Let's dive in. Before we get buried in technical terms, I want you to just remember one thing. At its very core, the gadget we're talking about does one job, and it does that job perfectly. It turns on, and it turns off. That's it. But doing that simple thing billions of times a second, well, that's what changed the world. All right, let's put a name to this little revolution. We're talking about the absolute, fundamental building block of our era. You could even call it the very atom of the digital age. It's called a MOSFET. And yeah, that stands for metal oxide semiconductor field effect transistor. It's a mouthful, I know. But here's the only part you really need to remember. It is a tiny, controllable electrical switch. And that word controllable, well, that's the magic ingredient. The absolute best way to picture this is to think about a faucet for water. Right? With just a tiny twist of the knob, you control a big flow of water. A MOSFET does exactly that, just with electricity. Keep that little faucet in your head, and this all makes perfect sense. Now, the MOSFET wasn't the very first device of its kind. And to really get why it's so dominant today, we've got to look back at what came before it, because that's when you see what a massive leap forward this was. So before the MOSFET took over, the king of the hill was something called the bipolar junction transistor, or just BJT. And for a while, it was great. It was the go-to component. But it had some pretty serious drawbacks that left the door wide open for something better. And this table right here breaks down the whole story. See, the old BJT is controlled by current. That means it's constantly sipping power just to stay on. But the MOSFET, it's controlled by voltage. Think of it like just putting your finger on the faucet knob to hold it in place. It takes almost zero energy. And that one difference is a total game changer. It means the MOSFET uses way less power and can be shrunk down to incredible sizes. That efficiency really is the whole ball game. Because each MOSFET uses such a tiny bit of power, you can cram billions of them onto a single chip. If you tried to do that with the old BJTs, the chip would waste so much energy as heat that it would literally melt. No joke. Okay, so we've got that the MOSFET is smaller and way more efficient. But what does that actually mean in the real world? Well, let's zoom out and just appreciate the unbelievable scale this thing's created. These aren't just parts anymore. They're like the microscopic brain cells of our entire modern world. Just take a second to look at this number. That's 2.9 sextillion. It's a mind-boggling figure, and it's a conservative estimate of how many MOSFETs have been produced. This makes it, by far, the most manufactured object in human history, more than all the bricks, nails, and screws ever made, combined. They are literally everywhere, and they are hiding in plain sight. The CPU that runs your computer? Billions of them. Your graphics card? Billions more. The chip inside your phone, your RAM, the electronics in your car, your TV, your camera. I mean, you get the idea. If it's a digital device, it's running on an army of these tiny switches. All right, so we've talked about the what, the why, and the where. Let's get into our last section and finally see how this amazing little switch actually flips. We're going to go back to our faucet analogy one last time to make it super clear. It's really this simple. In a MOSFET, the faucet's knob is called the gate. When you apply a tiny bit of voltage to that gate, that's step one, it creates this electric field that opens up a channel for electricity to flow through. Think of it like the valve inside the faucet opening up. That's step two. As soon as that channel is open, current can rush from the source to the drain. And that's your flow. That's step three. Take the voltage away from the gate, the channel closes, and the faucet is off. Simple as that. So here's the crucial point, the real magic of it all. A tiny, almost effortless signal on the gate gets to control a much larger flow of current between the source and the drain. It's all about that leverage. That's what makes it the perfect, microscopic, controllable switch. And when you take millions or billions of these simple on and off states, your ones and your zeros, and you flip them billions of times every single second, you get everything. You get math, you get logic, you get memory, you get the power to process a photo you just snapped or to stream this very explainer. It all comes from that one simple action, just repeated on a scale that's almost impossible to imagine. So the MOSFET was the switch that launched us out of the analog age into the digital one. It completely redrew the map of what was technologically possible. And that leaves us with a pretty cool question to chew on, doesn't it? What comes next? What tiny revolutionary switch is being worked on in a lab somewhere right now that's going to build the world of tomorrow?